Welcome, AP Stats students. We are going to continue looking at the idea of making inferences from our linear regression equations today. We're going to look specifically at making some inferences, some confidence intervals based on predicted values, making predictions from these linear regression equations. So just as kind of a jumping off point here, here's our information that we've had before about the grocery store. Remember, we surveyed 20 customers randomly, and we've asked them, how long has it been since you've been to the store, and looked at how many items they purchased. And we made a scatter plot from that and made this linear regression equation. And so remember, Y is the number of items that they purchased, and X is the days it's been since their last visit. So using our linear regression equation, what would your prediction be for the number of items that they would have purchased if they haven't been to the store for 5 days? Well, if they've not been to the store for 5 days, then 5 is going to be our X value. So substituting that into our linear regression equation, it would just be 4.21 times 5 plus 3.27, which is 24.32 items. So our prediction would be 24.32 items. Now, would you be surprised if a customer that had not been there for 5 days, if they did not purchase that many items, if they did not purchase 24.32 items? Well, probably not, because first of all, it's kind of hard to purchase 0.32 items, so that would make it impossible. But second, as we've mentioned before, there's going to be variability in this answer. Okay, we wouldn't be surprised if somebody purchased 26 or purchased 20 maybe even, because we would expect some variability in these answers. So what we want to do today is we want to put together a confidence interval where we could say we're 80% confident, we're 90% confident, we're 95% confidence that the range of items that they purchase would be within this interval. And so that's what we're going to be looking at today. So basically, we want to make sure that the things we've talked about before when we've made inferences, that those things are still true, that if we looked at the residual plot of our best fit line, that those points would be scattered on both sides. It would form kind of this cloud of data. You wouldn't have a pattern to it. You wouldn't see that as X increases, that the amount of variation increases, that there would just be kind of this cloud of information, cloud of points around our residual plot. So we're going to expect that. We also still want to make sure that our data comes from some kind of a random sample or a random survey. And so as long as those conditions are met, though, our confidence interval is going to be very similar to what we've done in the past. It's going to be a point estimate plus or minus a critical value that we look up times our standard error. And so in this case, our point estimate is going to be the estimate that we just talked about, the estimate that we would make from our regression line. Our critical value is going to be a t value, and we're going to use n minus 2 degrees of freedom, because there's two things that we're basing this estimate off of that have variability. There's the variability in the slope, there's the variability in the y-intercept. So that's one of the reasons why you can think of the fact that we're going to have n minus 2 degrees of freedom. And then the standard error, this is our equation for standard error. Now, there's actually should be a squared here. Basically, what we're going to do is we're going to find the residual values for each y point that we've observed. So y minus y hat for each observed value. We're going to add those, square those, and add them up. Divide it by n minus 2, again, from our degrees of freedom, and then take the square root of that. And that will give us the standard error for the estimate. Now, that's a complicated calculation. Imagine if we had to do that for 100 points, that would take us a long time to do. So again, this is going to be a value that we normally get off of a computer. And on our Google Sheets output, it is the one that's next to that r squared value. It's the third row down, the second one over. That's the standard error of the estimate. That's the SE, or sometimes it's just called S when we look at those outputs. So that's the number we're going to want to look at when we start to make our confidence interval. So here's our values that we would kind of get from our grocery store data that we've seen before. So it's laid out a little bit different than what the information is on Google Sheets, but all that we need is right there. So if we're going to make a 90% confidence interval for how many items a person is going to purchase if they've not been to the store for 5 days, where would we start? What would our point estimate be? Well, our point estimate is going to be exactly what we did at the very beginning of this video. It's just going to be plug 5 into our regression equation, and we get 24.32. So that's kind of our middle point. Now we're going to add subtraction values to that. Based on our outputs up here, our standard error, not for the slope, not for the y-intercept, but for the prediction value, is this value S right here, 8.34. So that's what we're going to use for our standard error. How many degrees of freedom do we have in this problem? Well, there were 20 data points, and so remember 20 minus 2, because we've got both x and y that we're estimating, and so that's why we get 18 degrees of freedom. And then if we have a degree of freedom of 18 and a confidence interval of 90%. Remember, we go to our t distribution table and we look that up. And so what we find for a t value for this, for t star for 90% and 18 degrees of freedom is 1.734. So you might look at that t distribution table, make sure that that's the value you read out of that table too. Now we've got all these key points. It's just a matter of putting it all together to come up with our confidence interval. So remember, our confidence interval is always a point estimate plus a t-score times the standard error. And so our point estimate in this case is 24.32. T-star is 1.734. Standard error is 8.342. And so that's what that's going to look like. So go ahead and figure out what confidence interval we would have based on those numbers. Okay, when we take 24.32 minus our standard error times our t-score, we end up with 6.24, and we do plus, we get 42.4. So that's a pretty broad range here, and part of that's just due to the fact that there was a lot of errors, a lot of variability in the amount of groceries people bought. And so, and you can imagine that would be the case if we actually looked at data from a grocery store. Some people go in and don't buy hardly anything. Some people buy a lot. And so we would expect to see a large variation there. So we don't have a nice compact answer here for our confidence interval, but we are saying, based on this confidence interval, that we're 90% sure that a person that walks into the store that's not been there for 5 days is going to purchase somewhere between 6.24 items and 42.4 items. Now, we might round that and say that we're 90% sure that they're going to purchase between 7 and 42 items, but we've come up with a confidence interval based on that prediction value. So in other words, when we make a prediction value, we don't know for sure it's going to be that value, but we can use what we've learned with confidence intervals all year to come up with a confidence interval for where we think that value is going to fall. So that's what you're going to be working on in your assignment today, is coming up with these confidence intervals for our predicted values. So again, if you have any questions on that, make sure that you ask about that. Just one caution, always as we're making predictions, as we're extrapolating from data, just remember that your data is only going to be as good as your random sample, and it's got to make sense kind of in the scheme of things. So I thought this was kind of a fitting cartoon to end with today. All right, well, good luck.